Good afternoon, everyone. I welcome you all for today's webinar. Last webinar was on financial mathematics. So, today we'll just continue with our series of webinar, which will be on the topic functions. Under the functions, we are going to explore the polynomial functions, wherein it will include quadratic, cubic, quartic, linear polynomials, and also inverse functions. Today's speaker is Mrs. Shraddha Nayak. So, over to you, ma'am. You can start sharing your screen.
Yeah, sure. Good afternoon, all. Today we will be looking at composite functions and not inverse functions, besides the polynomial functions. Just wanted to clarify that. So there will be a few questions along the way, and I hope we have our participants, uh, you know, share their thoughts and answer those questions. So we'll start soon. Just a moment. Yeah. All right. So the first. Uh, so yeah, so we'll talk about composite functions first, and as I said, I'm hoping you will be participating. Um, so, uh, so understanding composite functions is a two-level critical thinking part. The first part is the manipulation of the functions, which means it is an exercise, it's an operation you do on the function. And the other part is deeper, is critical thinking, is trying to understand how the domain and the range change uh, with respect to the functions that are used in the composition, right? So at this point, I'm hoping all of you have had some exposure to what it means to have a composite function. It means one of the functions will act as the domain of the other function. So all values that are input in one function, and let's call that f. If you substitute x in the function f, whatever the function emits or gives out as the answer goes back into the g function as its domain, and that is the principle of composition of functions. So why, is there a change to the domains? We're going to investigate that. Will the domains change? Will it really have effect on the domains of the function that has been composed? And what does it really look like when one function is substituted into another? So that is our preliminary kind of about 20-25 minutes to half an hour discussion about that. All right. So we'll move on to the first part. Okay, and I'm going to first. Give me a minute, please. I was starting. Yeah. Okay. So. Okay. So what I'm trying to do is get rid of these functions. So I want you to be able to look at that, and that has already been graphed. So I just want to make sure that I'm going to delete it. Okay. So we're starting with two functions. We're starting with a linear function, which is x minus 3, and a quadratic function, which is x squared, right? And we want to do composition of these two functions, right? So either we have f1 of f of 2 or f2 of f of 1. Now, we just want to investigate what really happens, and is there any change to the domain? So this is like an exercise. We will slowly be moving forward to slightly complicated functions, but when we start, we've started with really basic functions, right? And now I would encourage you to do these exercises along with me. So if you have your handheld or your software, loaded on your computer, I would suggest you work with me. And the way that you do that is you can go on the tab here. And if you see, I have kind of input these functions here as F1. And if I go down here, I have the second function. Now what I want to do is do the composition. So what I'm going to do is do F1. Now you might notice I've got a couple options. I could have done the algebraic working here, plugged in the x squared in the x value, or vice versa. But here I'm going to show you efficient ways of using the calculator. Since you have already defined these functions, I don't have to rewrite them. So what I'm going to do is say F1. Now you'll notice that it is bold because it's already been defined, of F2 and of X, right? If you notice, both have these been bolded because they have been defined, and I press enter. And if you'll see this another function that has appeared, which is a composite function using these two functions. Now what you might notice is that these things should occur to you as students of mathematics. You have to stop and reflect and question and say, okay, what do I notice here? You'd notice that this function here, which is F1 of F2 of X, it shares the y-intercept with this function, So in some way, this is related to these two functions. And if you see, its composition has led to this intercept. They're sharing the y-intercept. Let's try the other one. So to go on tab, and now I'm going to do F2 of F1. When I graph here, I get this function here. And you might notice that this function shares its x-intercept with this function, right? So there is something that's happening here. There's something that is happening here that results in its placement at these critical points, okay? And if I want to kind of investigate what happens, I could use graph trace. So I could go on to menu. I could go to trace. I'm showing you different ways of trying to understand the different features of this wonderful instrument, okay? Now if you see, the graph trace, the first point it is going to highlight is most likely the y-intercept. So it is kind of on this y-intercept here. And then if you use the up navigation button, you will have all values of these functions. So this is F1. When I click on this, it will go on to F2, but it will use the same X value. So let's try that. Okay, so if you see here, it's got the same X value. So this is graph trace. Okay, I'm tracing all the values of these functions when X equals 0. So this kind of helps you understand how these functions work. And then I try and do that again. And if you see, it's gone back to F3. And this is what I meant. You'll see that, oh, okay, this point is common to this composed function and the function that we use. So what is the composed function, right? So we said it is F1 of F2 of X, which means that this X squared is substituted to go in the domain, in the value of the X here. So it turns out to be X squared minus 3. So that is why this graph, if you've been introduced to translations, you'd see that this is a translation of the graph, right, of X squared. So this becomes X squared minus 3, and it moves or is translated vertically 3 units downward. And that is why it has got X squared minus 3. What happens when there is the other composition, the composition other way around? F2 of F1 of X, which means the X minus 3 is the new value that will be substituted in this function. So in this case, it becomes X minus 3 the whole square. So what happens is there is a horizontal translation by 3 units, and that is why this graph has moved 3 units to the right. So it's really interesting to understand what the composition really does. And if you were to look into domain and range here, this is a function. I've chosen this function for a reason, because these functions, both these functions, okay, have their domain, which are, okay, I would like, at this point, I'd like to ask a question to the students here. What is the domain of F1 function? So if I can have someone answer that. What is the domain of the F1 function? Hello? Hi guys.
Ma'am, we have an answer, all real numbers.
Wonderful. And can I have someone answer what is the domain of the F2 function? What is the implied domain of F2 function?
All real numbers again from Megha.
Yeah, wonderful, wonderful, right? They're all real numbers. So in this case, we've started with a really simple example of all real numbers. So in fact, there has been no change in the domain of the composite function. It is still all real numbers for the black function and the purple function. It's still, because we started with a simple, with both these functions had no domain restrictions to them. And that is why there was no change in the domain of the composed function. So let's move on to the next one. Okay, now this one here, right? We are going on to these two functions. Now you'd see, I moved on a little higher. We took the quadratic here. This is x squared minus 4. But then the function that I chose is a reciprocal function, right? It is a reciprocal function. And these functions, the reciprocal function has got domain restriction. Can someone tell me again? What is the domain restriction for the f of 5? What is the domain for the f of 5 function?
Ma'am, any real numbers except 0.
That's correct. That's correct. Who has answered that?
This was answered by Jia and Megha.
Okay, wonderful, wonderful. Okay, yeah, as you can clearly see here, this is called the vertical asymptote. It has no, the function is not defined at x equals 0, right? Now let us look at the composition. Now we've added an element of restriction here. So to add this, you're going to tab, and let's now do f5 of f6. So I'm going to do f5 of f6 of x. Right? Now let's think a little bit here. Okay. So now this is going to be the subject for this function. So what's going to happen is, since I've written f5 of f6, the f6, all the values that are spit out of the f6 function will enter the f5 function. So we can call this the inside function. If you know, just for very, you know, to understand what is really happening. So you can plug these values here, and it is going to be 1 over x squared minus 4. And let's graph this and check it out. Oh, this seems like a really complicated function here, because you've got 3 parts to the function. And now let's try and look at what is really happening here, right? So if you see here, right, if you see at these two functions, the green and the orange and the brown, can somebody notice something? Since this is an investigation, it is really important that you participate, okay? And can you tell me what is happening to this function? What is the combination of these two functions? What is the composition of these two functions resulting in? Any answers? Is there a change? Is there a restriction to the domain of this function, the composed function? Okay, so I'm going to move on and give you a hint. So if you have an answer, please hold on to the answer. Okay. So let's now investigate. Let's see, okay, what's happening here. So what I'm going to do is I'm going to use geometry and see if it is going to kind of shed some light onto it. I'm going to go to menu. I'm going to, not geometry, sorry, trace. And now I'm going to graph trace. Now, if you see here, right, it says this function here, which is for f of 5, as we rightly said, it's not defined at 0, right? It is not defined at 0. And then let us look at what happens for the next one. Let's go higher up. And then you say, okay, for f6, it is defined, right? And now what I'm going to do is go on to the y, to go on to the x-intercepts of this x squared minus 4 function. So to do that, I use my cursor to the right and I move the graph trace here, right? And when it comes here at 0, right, it is clearly, the trace function clearly identifies the critical point. So it identified the y-intercept, and now here is a 0. And then I'm going to move up and see if there is any change to this composed function, right? So I move up higher, and then you say, oh, so when there is a 0 of this function of the x squared minus 4, this composed function does not exist because it says it's undefined, right? Can anybody tell me or share what is the connection between the two? So let us go here, right? So what I'm suggesting here is that, so I can escape here. So we did see that wherever there is a x-intercept for this x squared minus 4, the new function that has been composed, it is not defined. Can anybody tell me what relation that is? What is the relationship between the two?
Ma'am, we have a chat.
Yeah.
The roots of f6 becomes asymptotes.
Wonderful, wonderful. So we do have asymptotes at the x-intercept. So you'll have one asymptote at x equals 2 and the other asymptote as x equals minus 2. Because this function is in the denominator, since the denominator cannot equate to 0 at those values, 2 and negative 2, for the resultant composed function, you will have asymptotes, okay? So now, so that it's really important to understand what is the connection between these two functions. So I'm going to move on to a few other slides and let us understand what composition of functions is, right? So here we have the domain of f. Any number that goes into any x value, these are x values, okay? These denote the x values. Any x value that enters the f function, it gives us an output, and that is called the range. This range now becomes the domain of the g function, and whatever that value is, this gives us the y value, which is the g of f. So what happens is the domain value here gives us out the range. The range of the f now becomes the domain of the g. And when that value enters the g function, whatever output it gives us, that gives us the range of g of f, all right? So I'm just going to kind of move this and show you how it is going to affect, right? So if this gives us this value, right? If this gives us this value here, it gives out, in goes 3, out comes 6. Now 6 becomes the domain of the g. When 6 goes in, you have another value for the g of f. So this is what is composition of functions. Now what happens really is we will have a problem if we have a value that you plug in the f, like 3 here, for an example 3, and you get a 5, but there is no corresponding, the function g is not defined for a value of 5, then you will not have a corresponding value of g of f. It will be undefined. So really from all of this, the function f function becomes really, really critical, right? So any value that has, so if you have this value here, right? If you have this value, I'm going to plug in, this is fine. You put in a 4, out comes a 6. The domain of g, the function g is defined at 6, and that is why you get an output of 1, because g function is defined at 6. But what happens when you get an output of 5? There is the function of g is not defined for a value of 5, and that is why you will not have a corresponding value, which means it is not defined for some, if some values that you get from f are not in the domain of g, then that function is not going to exist. So can somebody give me a rule? What is really, really critical for g of f to be defined? When will g of f be defined? Can someone give me that? Can somebody answer that? What is the most important critical rule for any function? For this example, we are doing g of f. So for g of f to be defined, there is one important rule that has to be followed. And what is that rule? Do we have a chat?
Not yet, ma'am.
Okay. This is good because people should be thinking. And I'm not expecting right answers here. Since this is a discussion, it is really, really important that, you think about it, you reflect, and you try and answer the question. I'm trying to see if there is a... Give it a go. Give it a go. I'm going to explain it again. Okay. This is critical. This is critical for higher level mathematics. All right. So,
Ma'am, we have a answer.
okay. All right.
Domain of inside function should also be considered in composite function.
That is right. That is right. I'm looking for a more clearer answer. What the domain? So, instead of domain, do you think of the two considerations between domain and range, right? Here, you are right. Neelam, you are right when you said domain of the inside function should be considered for when you are trying to find the composite function. But more than domain, what is really affected is the range. So if the range is in the domain of the G, the range of F is a subset of the domain of G, then and only then will you have G of F defined. So I'm going back to this one here, and I'm going to say, okay, yeah, domain, yes, that's right, but domain leads to range, and this range now becomes the domain of G. So if the range of the F function is a subset or belongs to the domain of the G, is within the domain of the G, and that is why I use the word subset. It is not outside. It is contained in the domain of G. Only then will the function exist. So it's very important to understand this, right? So as you see here, this value, this range value, okay, not the domain, like 3 here, you could have an output of 3 here, right? The domain of 3 results in a value of the range of 5. So what is really more important is the range value. This range should be a subset of the domain. If it is in the subset of the domain, then you will have the range defined. You will have an outcome, and that is why the G of F will be defined. All right. So let us graphically look at one example. All right. I've built this so that you understand, and they are linked. So I'm going to kind of just show you an animated version, what the graph looks like. So let me first see if my, so I've defined f of x is x minus 3. This is what we started with, really very, very simple functions. And x squared, I just want to see, right? This is one thing that I've built so that we understand this, okay? So now what I've done is, this is f1, this is f, and this is g function, right? And I'm trying to do g of f. So what I'm going to do is, there is a value of h here that I'm going to kind of find a value here. So I'm going to do, just give me a moment. So let's try this first. Okay. Just give me a moment. Okay. Yeah. So what I'm going to do is go to, there's one step of construction that is left. Let me try and see if that works. So I'm going to go to geometry. All right. You just have to look at it and not worry about it right now. I'm just going to take a point. All right. And I'm going to place it here for now. And I'm going to now the coordinates, and I'm going to store it as each. Okay, all right. So it doesn't matter. I have another construction for you. I'll get back to this one in just a moment. Okay, all right. So here we've got constructions. So I just want to, okay. So this is what I have picked, another function. I'll fix that one and we will look at that in just a moment. There's some complicated constructions to be done, which I have done in advance just to show you. So here there is a restriction of the function here for F2, and this is F1, all right? And what I'm going to do is I'm going to trace this, right? I want you to see what these functions looks like. So what we are going to do is look at g of f of x, okay? I'm going to do g of f of x, and that is why this point here, point H, I want to have a geometry trace, okay? So when I move the point here on F, okay, when I move the point F by animation, you will see the function that is resulting. So what we are going to do is do start animation. Sure. Okay. Okay. I'm going to start the animation here. Okay, hold on. Give me a minute. Okay. What I'm going to do now is move this point and I'm going to restart. Sometimes in constructions, you get, you know, things don't work always when every setting is not done. So y of g. Okay, hopefully it should work now. And I'm going to explain what this all is in just a minute. Okay. So, okay. So let's go here. And as we said, what I'm going to do is we're going to do, going to find composition of g of f of x. All right. Now, if you see here, if you look at my construction here, what I've done is I've said, okay, we've got the function f and its domain, if you see its range, which is y of f, is the range of f. I have linked it to the domain of the function G, right? If it is a subset, and that is what we are going to do here. So I'm going to right now start, reset the animation, and we are going to now geometry trace, and we are going to start the animation now. So if you see its function, what I'm hoping for you to see is that there is restriction. Okay, I'm going to take this back here, this one, and I'm going to kind of work again here to show you how it is restricted. Okay, I'm hoping that you see how the domain of f of g of x is restricted. Okay, if you'll see the new function here, the green function only goes between 2 and -2, and that was my hope to show you. So what I'm going to do is we'll take it back to its original position. Okay, I have to stop this one here. Okay, here I have to go back, and if you see, I've got to reset these settings here. But I'm hoping you can see how restriction is caused. So okay, let's start again here. Right now, I need to kind of place this again because it loses its geometry trace. Okay, and now I'm going to start my animation. Hopefully it works fine now. No, it doesn't. Okay, all right. So what I was trying to to get to you is that this function here is restricted. If you see, if we go to the composition of these two functions, right? This function here is going to restrict the domain of g of f of x. So what happens is the f of x, which goes in here, right, goes in here, it can only, this minus x squared plus 4 will only work, this composition will only work if your graph lies between 2 and -2. So unfortunately, I could only get this to work at half the thing, but what you would have seen is that this function would move like a semicircle. You would start from here and get a semicircle back here. This is what I was hoping to tell you, that though the x squared plus, this is minus x squared plus 4, the domain of this is all real numbers, and the domain of the square root of x is all real, x greater than or equal to 0. The combination of this results in such a way that the domain of the composite function gets restricted. Okay, so let me just try this once more to on this function here, and let us see if my construction is all correct. So, right, and I'm going to just try it here. Okay, so we are looking for so yeah, let's try this one here. Okay, so I'm going to now animate, I'm going to trace h. All right, I'm going to trace h. So I do geometry trace for h. So h is the composed function, right? And it is a composition of f and g, right? I'm going to start the animation, and let's see how this works. Okay, I hope it works. So if you see, right, f of g of x, the composite function, is a resultant of this, and that is why this has been restricted, because this values will determine what the domain for this function is, right? I'm going to stop. So hopefully this worked, all right? So That is how the domain of the f function will result in the range which goes in the g function, and that is why how that is all related. So it's very important to go back and understand this part here. Okay, so the range of f has to be defined in the g, and only then will this function be defined. It will not be defined at all values, just like we looked at this one here, right? When we did here, right? If this function is not defined for x less than 0, it is only defined for x greater than or equal to 0. And though the domain of these functions, right, matters how they combine together to produce this function. Right? Okay. So this is one thing here that I was hoping to get across. The other part that I'm going to talk about is talk about sum and product of roots. Now, sum and product of roots formula is not given in the IB formula booklet, and that is why I'm going to kind of just see if we can do a few things with that one. Okay, so let's start with a new problem. Okay, let's start with a new problem. You go to doc, all right, you insert and you insert a problem. Okay. And what I'm going to do is start on the calculator right now. I want to show you a few things. Let us do polyroots for, so one way to get to polyroots of any polynomial is you can go to the menu, okay, and you can go to algebra, and you can do polynomial tools. Okay, you find the degree, let's say it is 2, real or complex, whatever you think. So let's go for complex, and I'm going to go okay. And let's say this is x squared, so 1, 0, and 4. Let's say this is, okay, let's say to this one here. So it's x squared plus 4, and if I want to find the poly roots, this is what I get. These are complex roots, right? So I can, the other way I could do is just use this poly roots. You could type poly roots, right? And this will give you real roots. And now let us write x squared minus 4, because that will give you real roots, comma x, right? Poly roots, comma x. And if you press enter, this way you can get your roots, right? Now we are going to find sum of the roots, right? So what we can do is you can type in sum, okay? And what I can do is do here, I can go to do polyroots. So you can go up, you can use your navigation, or you can do Control C, Control V. And I'm going to type in here, right? So it becomes so much easier. And then I'm going to press enter. And the sum of these roots is 0. And as you can see, the sum of the roots is 0. Minus 2 plus 2 gives you a 0. Now let's see if it works with products, right? Product. So I'm going to write product. And I'm going to use the same example. And okay, I'm going to kind of do here and click here, and it gives me minus 4, right? So the product, yes, if you can go back here and you can check, minus 2 times 2 is minus 4. So there's something here really happening, and I want to see if I can kind of generalize this. So to be able to generalize this, I'm going to ask you to, I'm going to show you a few features on the TI Nspire, all right? So let's now define a polynomial, and let's say it is P of X, okay? And I'm going to define it. For defining, one of the ways to do is to use this notation, all right? And I'm going to write here as 2x squared. Again, we are doing sum and product of polynomials. So 2x squared plus 2x minus 1 and I'm going to define it. And now I want to find the sum of the roots. So again, I can do sum. Okay. Now, since I've defined, I do not have to rewrite the entire polynomial. What I can do is just write p of x. Okay. And you have to write x. Let's see if it kinds of, sorry. Right. So it still gives us the sum, and it will also give us the product. If your function is defined earlier, you don't have to rewrite the function. If you have the function defined, you can still use it. So let's do the product and check. And slowly we are going to build this up to other polynomials as to cubic and quartic. So let's do this. And again, I'm going to use the same polynomial here. And I'm going to say, oh, it's negative half. All right, the product is negative half. Now you see, I do not know the roots. I do not know, I haven't found out the roots. Like in this example earlier, what we had done was we found out the roots and we found out the sum and we verified. We said, okay, yes, that sounds right, because the sum -2 plus 2 is 0, -2 multiplied by 2 gives you -4, right? And that works. And now you can use this feature here because you do not have this on your formula booklet. And if this is a paper 2 kind of a question, you still can use these methods to get to your sum and root answers. Like this is -1 and -0.5. Now, what I'm going to ask you to investigate, all right, let's create. So what I'm going to do is I'm going to randomly find a polynomial, okay? And this, I'm going to say, okay, it is going to be in variable x. This is a new feature that I just discovered, okay? Your random polynomial uses the variable x and you want a cubic. So what I'm going to do is I'm going to write the degree of the polynomial for a cubic, which is 3. And then I'm going to now press enter. And it randomizes. It gives me a random polynomial, which is a cubic, because I defined it as a cubic in the variable x, right? And now I want to find out what the sum and the product of this polynomial is. So what I'm going to do is I'm going to write again here. I'm going to pick this up, copy this again, and I'm going to use the new polynomial that I have randomly kind of found out, because I'm investigating the sum and product of rules. I'm trying to find out what is going, how are the coefficients of the different terms of the polynomial going to influence the sum and the rule. So what I'm going to do is now find the sum of this polynomial, right? And I've got to kind of say it is defined in x. Now I want to find the sum of this one. Plus 4. Okay. It gives me 0.33. Now this is very familiar. This is 1/3. Can someone tell me any relationship that you see between the polynomial here and the sum? So let's kind of first go back here and look at a very simple example. All right. Let us look at this here. And the sum of the roots are defined or are found or evaluated using these coefficients, like the coefficient of 1. There is the coefficient of x is 0 and the coefficient of the constant is 4, right? So it has got to do something with the coefficients, and you get a 0 here. And these terms, so if you find here, you say, okay, I think this -4 has got to do something with the constant. This 0 is possibly got to do something with the x coefficient, because the coefficient of x is 0 here. There is no term in the there's no linear term. So the coefficient of the linear term is 0. So there is just perhaps connected something to the coefficient. So using that information, I'm trying to ask you if you can find any relationship between these coefficients and the sum and the product. So what I'm going to do is going to show you another, I'm going to help give you another example here, and let's see. So what I'm going to do is keep some of these values the same and change some of those so that you come to some conclusion. So what I'm going to do is do sum, okay, write polyroots. And now what I'm going to do is change this to 3x cubed. And I'm going to not change the other parts at all. I'm not going to change the other parts. So what I'm going to do is write them as they are. And now let us find the sum. So this is in an effort so that you can see something happening. Can anybody tell me what is happening here? I'm going to do one more before you come to the conclusion. Okay, so I'm going to, in fact, take this entire thing, copy, I'm going to paste it here, and I'm going to change just one value here. I'm going to change this value here, right? And I'm going to press enter. Can somebody tell me what you can see between these three examples that I have done for the sum? Do I have anybody sharing?
Not
Right.
the sum of the roots is minus b by a.
Okay, minus b by a. Is it always going to be minus b by a? Let us see if this works for our quadratic, right? Did it work for our quadratic here? Yes, minus b over a, because this minus b was 0, and that is why you had the sum 0, so it worked here. Let us look at this example that we did here, right? And we said it was minus b over a, and by minus b, I think you mean the coefficient of the linear term. So it is minus 2 over 2, and you did get negative 1. Wow, that's good. All right, and let's look at the couple examples that we did here. We said, okay, so let us try and look at this one. So minus b, which becomes 3 over 9, is 1/3. So you're right, wonderful, going well. Let us do here, minus of minus is a positive, 3 over 3 is a 1. So that sure indeed really works. Negative times negative is a positive, 3 over 1 is a 3. Now let us randomize. Okay, let us see if it works for quartics. So what I'm going to do is find a random polynomial just to find if my observation is correct, or will it work for polynomials that are greater than the degree of 3. So what I'm going to do, as you know, what I'm going to do is say x is the variable, and I'm going to try it with 4 because it's going to give me a random variable. Now I'm going to do sum polyroots, because this is sum of the roots. It is important that you have the polyroots typed in. And now I'm going to take this entire polynomial and I'm going to kind of plop it in, right? And now, since one of you said it is going to be minus b over a, I'm expecting, what is the answer? Can some other participant give me the answer? Not the person who said the answer to the earlier question. Can I have one more participant to give me an answer for the sum of these roots, sum of the roots for this polynomial? What is it going to be? Can I have someone answer the question? It is minus b over a, right? So what is going to be? It is minus of minus 5, which is 5 over negative 2. So it should be negative 2.5 if our observation is correct. Oh, you still have to put the variable x in here. So going here, we put the variable x. Remember, we've got to define it. Without defining, it gets confused, and then you have negative 2.5, right? So it is minus b over a. So this is a powerful tool to kind of investigate if you've come across. Now let's look at the product, all right? Let's see if we can find something for the product. Again, we are going to randomize. So since we have already found this polynomial randomly, what I'm going to do is instead of the sum, I'm going to type in product. So if you see how easy it is to kind of use investigations on TI Inspire, because there are a plethora of applications that you can really kind of use to kind of find out. Okay, just hold on. So we were doing this instead of the right? Okay. So one way, the other way to do this is to, let's say we don't get it. Anyway, I get a chance to kind of show you what we can do, right? So I'm going to go down here, and this is what I intend to copy. So once it is here, I just press enter, okay, and I get here. This is one of the other features, and instead of the sum, I'm going to use product. This is all I have done. Instead of the sum, I want the product of the same polynomial, right? And we are trying to find out a rule. We're trying to find out whether there is a rule to find out the product of roots of polynomials. And then you are going to press enter, and we get -4, right? So you get -4. Now I'll give you a hint. It's got something to do with the last term. It's got something to do with the last term. So if you see, this is +4, this is -4. So there's something that's happening here. Let's try with this one here. So I'm going to go up to this one, and I'm going to enter. So if you see, if I can just copy, if I highlight that part, and instead of the sum, I'm going to do a product, right? And I press enter, and I get -3. So I'm going to investigate now. I want to say, okay, what is happening? So definitely this is, so if you see, there is some kind of influence of the last of the constant, right? And the first coefficient. If you see 4 and 1, right? This is a cubic, it is -4. So you see the numerical combination here. And if you see, oh, this is 6 over -2. But if it were negative, can somebody shed some light on the product? Is anybody prepared to kind of contribute for the product? What relationship do you see between the constant and the coefficient of the leading term? How is the product decided by these two factors? Can somebody contribute, please?
And we have an answer. It is C by A, constant by leading coefficient.
Constant by leading coefficient?
Yes.
Do you think it's a constant by leading coefficient? Let's try. Let's do 4 over 1. Did we get 4? We got a -4, right? We didn't get a 4, because if the coefficient of the constant term is 4 and you divide by 1, which is the coefficient of the leading term, you should get 4, but you get -4. So let's assume it is negative, just like we had negative b over a. Let us assume, looking at this example, it appears to be that it is negative c over a. But let's then try this. Let's try over this and say, okay, if this kind of works, if negative c over a works for this, let me try if it works for the quartic. If you see, this is a quartic function. And if I do here and I say, oh, this is c over a is 3, but negative c over a should be -3. So there's something that happens with the negative and the positive signs, right? So let us investigate. Let us go back to our quadratic. Let us go back to our quadratic. And we found the product here. We found the product here for the quadratic. And if you saw here, oh, it does appear it is -4, right? It is -4. So this is -4 over 1, which is -4. So it does appear that for even for polynomials with even degrees, like a quadratic and a quartic, yeah, it is C over A. But for odd polynomials, it is negative C over A, right? Let's try this once more. Let's try and see if this works for, uh, 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 so let's try product, okay? Let's do polyroots, okay? And let's this time take a quintic, because that is a odd degree polynomial. Now, if you have seen what really happens with these in between coefficients, it has no bearing on the product. We are only really worried about the constant and the leading coefficient. So what I'm going to do is write a quintic function, but this time I'm going to say it is 3x raised to 5, and I'm not really bothered about the terms that lie in between, and I'm just going to go with the negative 15 as my constant, okay, as my constant. So since this is a quintic function, and of course I need to write the x, identify the variable, right? Okay, so if it is an odd polynomial, then it should be negative or C over A, which means now C over A is negative 15 over 3, and negative of that is positive 5. So let's see if we get positive 5. Oh, don't know why this is not working. Let's try with another one. Hold on. Okay, just a moment, guys. Let me. Wondering what has gone wrong here. Yeah, I don't know why this is not working, but it should be. Let me figure that one out and come back to you on this one next class when we meet next Saturday. But this should be, it is negative C over A for odd, and it is, I wondered if there is I've done something incorrectly while plugging in the uh, operator. So I'll come back to you on this one, but it is negative constant here. The negative for an odd, it is negative constant over the leading coefficient. So here it would be, since this is a quartic, it is going to be positive, and if it is a cubic, it is going to be negative constant, which is negative 4 over 1. For a quartic, it is going to be negative 6 over negative 2, which is 3. So I will figure what went wrong here, why we didn't get the answers correctly here, and I will come back to you. But it should have been for a quintic, it is negative of negative 15 over 3, and it should have been 5. Okay, so I am confused about why this did not work here, and I'll come back to you on that one. Okay, so I've got just a couple questions for you at the end here. Okay, and can someone tell me what the answer for this one should be? If I can have someone give me the sum of the roots of this without knowing the roots, you can find the sum of the roots. Without knowing the roots, you can find the product of the roots. Can someone tell me what the sum of this polynomial, the roots of this polynomial is? Hello? Can someone tell me what the sum of the root of the,
We have an answer from Gia, it's -2.
it is negative, is the sum is -2. Yeah, it is
Yes.
negative b over a. And what is, Gia, what would be the product of this rule of these roots? It is a cubic. It's a cubic. It really matters. The degree of the polynomial matters for the product. So what is it? The product is negative of c over a.
And we
So
have an answer again from
yeah,
Gia, it is 6.
it is 6, right? Because if this was x raised to 4, if this was x raised to 4, then it would have been negative 6. So instead, if you have got x raised to 4, so here, if we have got the product, right, and we do polyroots, and then I could have written px, right? I'm just going to kind of write this here, okay, and x here, and then we have the product here, right? But if this were x raised to 4, if this were x raised to 4 instead of x raised to 3, okay, yeah. So there is something that is that's not working right with this one. I do not know. We have had problems with the last one as well, but here we should have gotten 6 as the as -6 as the answer for the product, because it is minus of -6 over 1, which should have been -6. So there is some kind of uh, problem with this application, and I'll come back to you on that one. Yeah. All right. Swati, if students have any questions, I can answer them, or otherwise, I think you have a quiz for them, so that will be good.
Uh, yes, ma'am. Please, students, if you have any questions, do ask us. Else, we'll continue with the quiz.
Okay. So if there are no questions, then yeah. So Swati, you can proceed with the quiz, and I'll try and find out if I can the next 5 minutes or so what went wrong in our application. Okay.
Okay, okay. Yes,
Yeah.
ma'am. Thank you so much for this wonderful session. Now, students, what we have learned, we will have a short quiz on what we have learned today. So I request all of you to open your Google browser and input joinmyquiz.com. I've written in the chat also. Just enter joinmyquiz.com. And once you're on the page, I'm going to share a code with you. Joinmyquiz.com. And the code is 354550. 354550. The code is 354550. All of you, please join the quiz. Please input joinmyquiz.com and the code is 354550. Megha, Nilima, I'm waiting for you. Please join the quiz and others as well. Let me know if anyone is facing any kind of difficulty.
Swati?
Yes, ma'am.
Yeah, I figured out what it is. If people are online, can I just clarify?
Yes, you can.
Yeah, because just ask them to hold on, guys, please. Yeah. So the thing was, since we have complex roots and real roots, right? This is not it just gave you the product of the real roots. So what you have to do, you have to write complex roots. So it should be product of C polyroots instead of just polyroots. All right. So what we stumbled here, I'll go back to the one that we stumbled on, and I just want to, so that we do not leave with any questions here. We said we have to do this product of this one, and we got an incorrect answer. And so what we had to do was, instead of polyroots, you had to do complex roots. And now when you do, since this is a quintic, it is negative of negative 15 over 3. So the answer should be 5. Let's see if we get 5. And that is why this is 5 plus. This is a 0. It is a complex root. That is why you got 5 plus. And this one, 1.3797 times 10 to the power of negative 13. This is equal to 0. So you should know that you have to kind of ignore this, right? So the answer is 5. All right. Let's do one more just before we go on here. This one. Let us try the one that we started with here. This one, we didn't get the answer. We did not get the right answer for this one. So I'm going to do that again here, right? So that we avoid any confusion. There was no error in the application. You just had to do complex polyroots, a very important thing.
Ma'am, we can't see the screen.
Oh, that's because, okay. Thank you for just a minute. Let me see, let me share. Thank you. Yeah, okay, all right. So I'm going to just, I'm going to try this right from the beginning. All right, this one, when we said product of polyroots, right? And we were expecting, since this is a quartic, it is going to be negative C over A, which is negative 6 over 1. And we expected negative 6, but we got negative 1.42463, and that was quite a surprise. So what this is the sum of, this is the product of real roots, because if you see there, we have not included the complex roots. So you've got to include the complex roots. Is the product of all roots, including the complex roots. Now this one, if you do this, you see this is negative 6, right? It is negative C over A, and this part is equal to 0. You should know this is calculated notation. E raised to negative 14 is 10 to the power of negative 14. So this is 0. Any number multiplied by such a large number, which is raised to 10 raised to negative 14, is 0. So this is a calculator notation. You should understand that this is 0. So the answer is negative 6 over 4, right? And this is one other thing that that you couldn't kind of we couldn't get in here. Just a moment. Which one? Give me a moment here. Okay, so we were struggling with this one as well earlier. We said, oh, we tried this one and product of polyroots, and we got 1.37973, and this was quite a surprise. We said, oh, what went wrong there? So I'm trying to copy it again and entering it as complex roots. Okay, so now that all roots, so this is going to have real roots as well as complex roots, right? It is going to have 5 roots, and the product of all those 5 roots is going to be, now this is a quintic, so it is negative of negative 15/3, right? It is negative of negative 15/3, so you should get an answer of 5. So let's do this, and that is why you get an answer of 5. As explained earlier, this one is equal to 0, so you should know that you have to ignore this in calculator applications. Okay, I hope I made that clear. You've got to use the C polyroots and not just polyroots. Okay, all right. Do I have any questions?
Not yet, ma'am.
Okay, all right.
It's clear, yeah.
Yeah. Okay, so you can continue with the quiz. And
Yes, ma'am.
I will, yeah. Bye, students, and see you next Saturday.
Thank you, ma'am. Okay, I'm just sharing my screen and I'm starting the quiz. Here comes your first question. State the maximum and minimum number of zeros. You just need to find the number of zeros, maximum and minimum number of zeros. Plot the graph and check. So the correct answer is fourth option. Second question. The graph is given. Which graph matches the question? Alright, the correct answer is option 2. Next question. Find the y-intercept of this quartic polynomial. Y-intercept. Option B is the correct answer. Next one. Again, find which graph suits the question. Option B is the right one. Find the zeros. First option is the right one. Next question. When is this function increasing? From the graph, when is this function increasing? Next question. This is a composite function. Find f of g of 4. So the correct answer is 39. So yes, Gia, you were on the top. So I hope the session was informative. And next webinar will be on 28th of November, and it will be the continuation of the functions unit. So see you all in the next webinar. Thank you once again for joining for this webinar. Thank you.